Welcome to today's Explainer. We're jumping right into a really fascinating look at the hidden technology powering our modern world. I mean, think about it. Batteries have quietly become the absolute most important component in our daily lives. They power everything from that phone in your pocket to the car sitting in your driveway. But fundamentally, a battery is actually just a box of highly volatile chemical systems. So today, we're exploring a massive shift, how the artificial intelligence of things, or AIoT, is stepping in to transform these unpredictable chemical boxes into completely safe, highly predictable, and incredibly smart energy networks.
To really appreciate the solution, we kind of have to understand the stakes first. What turns a seemingly safe battery into a catastrophic fire hazard or, just a frustrating piece of dead weight? You've probably seen the headlines, the really tragic incidents where unmonitored batteries in Ola scooters actually caught fire, or those highly inconvenient cases of Volkswagen EVs just going completely dead after being parked for a couple of days. These real-world, high-stakes failures happen because, without continuous monitoring, these complex chemical systems degrade, overheat, and fail in ways we just can't predict.
So here is our roadmap for today. We'll start with the hidden battery crisis, then look at the evolution of battery management. After that, we'll break down the big three metrics, check out AI in the real world, and finally, wrap things up with the second life economy. All right, part one, the hidden battery crisis and the real dangers of unmonitored systems. We really have to confront just how unstable lithium-ion systems can be when nobody is watching them. An unmonitored battery is essentially a total black box. It leaves you completely vulnerable to unexpected downtime, random failures, and worst of all, thermal runaway, which is that uncontrollable reaction that causes those toxic fires we talked about. But the moment you introduce an AI-monitored system, the whole game changes. By continuously tracking the data, we get early warnings, we can do predictive maintenance to stop downtime before it happens, and we can isolate faulty cells long before they spark any sort of disaster. And get this! The warning signs of a disaster are actually incredibly specific. Research from the National Institute of Standards and Technology identified a very unique click-hiss sound that lithium-ion batteries make right before they enter thermal runaway and burst into flames. It's a crazy, visceral detail. These batteries are quite literally giving us acoustic warnings that they're about to fail. So the problem historically hasn't been that the battery isn't warning us, it's just that we haven't known how to listen. Moving on to part two, the evolution of battery management from reactive to proactive. Enter the battery management system, or the BMS. Traditionally, think of the BMS as the electronic brain managing the battery, monitoring its state, keeping it safe, and balancing it. But here is the major limitation. Traditional systems relied on very fixed, rigid models. They used these set mathematical approaches, like Coulomb counting and Kalman filtering, which were strictly calibrated to rigid voltage and temperature parameters. And the issue is, those fixed rules are completely useless when it comes to adapting to the messy, nonlinear ways batteries actually age in the real world. Now, what's really interesting about this is the massive architectural shift happening right now. We have officially moved away from those rigid, rule-based if-then setups, and we're moving towards dynamic, AI-enabled frameworks. By using cloud computing, deep neural networks, and digital twin simulations, a modern BMS doesn't just blindly follow a rule. It actually learns hidden patterns, hidden deep within massive amounts of data, so it can proactively adapt and predict what's going to happen next. That brings us to part three, the big three metrics for predicting degradation. Okay, let's dive into this. At its core, AIoT and battery tech is basically constantly answering three specific questions to prevent sudden failures. Step one is the state of charge, or SOC. This is simple. It's how much energy is available right this second. And advanced deep learning models can actually predict this now with an error margin of less than 2%. Step two is the state of health, or SOH, which measures how much capacity the battery has lost over its entire lifespan. And finally, step three is remaining useful life, or RUL. This predicts exactly how much longer the battery can safely perform before you absolutely have to replace it. Nailing these three numbers down is literally the difference between a perfectly reliable system and a total catastrophe. Let's look at part four, AI in the real world, focusing on industry wins and safety. Remember that click-hiss sound we talked about earlier? Well, through rigorous training on audio samples from actual battery explosions, AI algorithms can now detect that exact sound of imminent failure with 94% accuracy. And it can do that even in super noisy environments.
But here is the best part. The system can detect this sound about 2 full minutes before the catastrophic fire actually starts. In the real world, that is literal life-saving evacuation time, provided entirely by AI.
And the benefits go way beyond just safety. We're talking incredible performance longevity, too. Take a look at Tesla. They've achieved something amazing, retaining 90% of their battery capacity even after driving over 200,000 miles. So how is that even possible? It's all powered by AI. Tesla uses these proprietary neural networks to continuously analyze thousands of individual cells. Their liquid cooling system uses machine learning to proactively predict thermal conditions and dynamically adjust the cooling. Plus, they analyze real-time weather, traffic, and your driving behavior to give you super accurate range predictions. It is just a beautifully optimized system.
But running these systems, especially when you scale up to the grid level, is a really complex balancing act. It requires something called multi-objective optimization. For example, you want to minimize the charging time, right? But you also want to minimize battery degradation. Or for utility grids, you want to maximize energy dispatch to make a profit while somehow maintaining perfect voltage stability on the grid. Humans just can't calculate that fast enough. So AI steps in, using advanced evolutionary models, like genetic algorithms, to systematically explore all those competing variables and find the absolute perfect sweet spot in real time.
Finally, Part 5, the Second Life Economy and Sustainable Energy Reuse.
Here's a crazy fact. When an EV battery is retired from the road, it actually still retains 70 to 80% of its original capacity. There's plenty of life left. The challenge, though, is that these second life batteries have wildly varied degradation patterns, so you can't just plug them all together into one big battery pack. And this brilliantly illustrates what companies like Redwood Materials are doing. They are using AI to solve this exact problem. They actually built a massive 12-megawatt microgrid entirely from repurposed EV batteries to power a data center in Nevada. The AI acts as the conductor, constantly characterizing the condition of all these mismatched batteries and managing them as one incredibly cohesive, optimized system.
As we wrap up this explainer, I want to leave you with a final provocative thought. We've seen how AIoT can take a volatile chemical box and turn it into a highly predictable, safe energy system. But when you look at the potential of the second life economy, we really have to ask ourselves, how will AI not only power our cars, but fundamentally change how we consume, manage, and recycle all of our global resources? The fusion of AI and battery technology is clearly about so much more than just better vehicles. It's literally the foundation of a sustainable, circular energy future. Thanks so much for joining me for this deep dive. Keep learning and stay curious.